Okay, Swift generics. Here's a complicated topic. What are generics and how can we use them? And I'm going to use a Dungeons and Dragons example to make it a little bit more fun. But essentially, generic code enables you to write flexible, reusable functions and types that work with any type subject to requirements you define. So it's basically a way for you to kind of get around the whole super crazy type safe world of Swift. You know, Swift typically wants you to specify int or string or whatever, but sometimes you want to pass in various objects or types into a function. So let's take a look. I'm going to open up a Swift playground here. So I'm going to make a new playground and we'll just call this generics, an exploration. Oh, generics Firebolt. Okay, so I play Dungeons and Dragons, and let's say I want to make a function that is to cast the Firebolt spell at a creature, right? So no problem, function cast Firebolt at, and it's going to be at a creature. Well, right away we got a problem because we didn't define creature, right? So creature looks like it's, what is that? It thinks that's a thing? Okay, yeah, creature's not a thing yet. So we got to make a structure called creature, right? So I guess our creature's going to have a name and some health of type int. And let's just start with that, okay? So that's fine. Let's throw in a print statement here just to make it expressive. Whoosh. Boom. Crackle. You hit. We're just going to assume it hits. You hit the. You hit the creature's name. I will just say you hit the creature name. Okay. So now let's say we've got this creature. Or let orc equal creature and give it a name. The name orc. The health we'll say is 10. Okay, fine. So now easy enough. We can just use their cast firebolt at creature, and we can cast the firebolt at the orc. And let's run this and see if it works. Whoosh, boom, crackle, you hit the orc. Okay, so hopefully you're with me so far. If you need to learn more about structures or functions, then I've got videos on that. But you know, let's say we're playing Dungeons and Dragons, and the player says, "Well, I want to cast Firebolt at the door because I want to try to break the door down." Okay, well, we got to make a thing called a door, right? So structure, we'll call it, let's call it an object, okay? Object. And we'll give the object a name. And we'll give the object some health. And, well, it's a door, so let's give it a material also. Material. Maybe it's wood, maybe it's stone. We'll just make that a string. Okay. So now you've got this thing down here. Instead of an orc, you've got this thing called a door, and it is a object. Let's say it's got 18 health. I think that's the amount of health for a wood door in Dungeons and Dragons. All right, no problem. Let's cast Firebolt at the door. Now let's see what happens here. Run it and it crashes, right? You can't convert the type object to creature. So the door is an object. It's not a creature. You can't cast your Firebolt at it. Well, so what if we want to do that? What if we want to, well, fine. Then we got to make a new function, right? So we're going to copy this, and we'll make another function here. Instead of creature, it's going to be an object. So object there, object there. So cast firebolt at object, whoosh, boom, crackle, you hit the object name. So now we should be able to use the other function we got where it's like object door, cast firebolt at object door. Cool, right? Fine. What if the player is like, I want to cast the firebolt at the air? Well, then you've got to get another function here. And so you see how you end up having a bunch of different functions that do the same thing. And when you got a lot of duplication like that, it's a good idea to look into, how to refactor your code and maybe make it better. Now, before we move into generics, we should probably get into protocols a little bit first. So let's take a look at our structure up here. And one thing I like to do is if I'm looking at my structures and they have like a lot of the same elements, then I might think about how to use protocols to define that. So because like if I use a protocol, then I don't have things like this happening where it's like sometimes it's called a name, sometimes it's called a title, sometimes it's called health, sometimes it's called HP. If they adopt the same protocol, then stuff's all named the same. It helps me out in the end. So first of all, let's look at this name. So I guess a simple protocol for that would be, let's call something nameable. Nameable. And the nameable protocol we'll say is just it's going to have a variable. It's going to be called a name. It's going to be a string. And you got to get that name. Put the little get in there because we got to get the name. Okay. So to adopt the nameable protocol, no problem. We'll just put, we'll say it's nameable, right? And then objects are also nameable, clearly, because there's a name in there. And health, there's a health one. So I guess that would be protocol, let's do damageable. Okay, same kind of thing as this, except it's not, it's going to be a health. And it's going to be an int, and we're going to get that. Now, you'll see all these are already adopting the protocol, but let's say this one didn't have the health thing there, and I try to adopt damageable. Then it's going to yell at me, and it's going to try to insert the stubs there. You can just hit the fix button, and then it inserts the health in there, so that way we don't forget it. So, damageable, nameable. Let's look at one. Let's get really extra nerdy here, okay? And let's look at Firebolt. Okay, so here I am at the roll20.net. I looked up Firebolt, and here is the text for Firebolt. You hurl a motive fire at a creature or object within range. Make a ranged spell attack against the target. On a hit, the target takes 1d10 fire damage. So this word target keeps coming up. So it's got to be something you can target. So for that reason, I want to make a protocol, and I'm just going to call it targetable. And I'm not going to put anything like in the requirements for that, but I am going to still adopt the targetable protocol here for these, because like you can target objects. I'm going to assume you can target creatures. Let's think of something you can't target, like the air or something. So we'll make a structure, call it gas, and that is got a name, but it doesn't have a target. You can't target it and you can't damage it. Okay, so if it's got a name, then we got to add the protocol stubs for that. Okay, so now what, right? Now what? So basically, at this point, what I want to do is I'd like to make a function that's kind of like these functions, except it takes these protocols as, let's take a look at our error here. Argument health must precede argument name. Oh, it doesn't like the order of that. All right, fine. Let's just change the order in this so it matches, right? Cut it out. You're so picky, Apple. There you go. Better? Better. Okay, fine. And so now we got this thing. We'll just put in air here. Air, it's of type gas. And it's got a name. And the name is going to be air. Okay, so now at this point, we can cast Firebolt at a creature, or we can cast Firebolt at an object with these two functions, but we certainly can't cast the Firebolt at the air, and we still have two functions here. So how do we make these two functions into one function? Well, one way to do that is let's use these protocols to specify the type you pass in. So you can do something like this. Cast Firebolt at, and then it's going to be something that's like nameable, damageable, targetable thing. So of type, and then nameable. I don't know if you can do this. We'll see. And damageable and targetable. Not very expressive, right? I mean, whoosh, boom, you hit the nameable, damageable, targetable thing, right? So you could do this also. Then you could just get rid of these two, technically speaking, and just use this thing that's adopting these protocols. Now, this is a little bit like wordy, right? It doesn't look very good. So let's do something a little bit better. And we're going to use something called a Typealias. I'm actually going to comment this out because I really don't like it. But it's got the right idea. Nameable, damageable, targetable. So I'm going to copy that. And I'm going to say Typealias. And what are we going to call this? Let's see here. Let's think about it. Let's call it attackable. So let's make a thing called attackable. So like instead of a string or an int or whatever, we're going to say this thing is attackable, and it is attackable. When we say attackable, we mean it's nameable, damageable, targetable, and then this function down here will look a lot better because we'll just put like cast Firebolt at attackable thing, and here is the attackable type. So, and I think I'll just make this attacked. Cast Firebolt at attack name. Now, anything that conforms to all three of these things, we can attack at. So we could really get rid of these two functions down here and say, cast the Firebolt at the attacked thing called an orc. Or cast the Firebolt at the attacked thing called a door. So that's one way to do this, okay, is you use protocols and you can create your own Typealias protocol so that you can simplify your functions. Now there is another way to use something called a generic, and that's what this whole lesson's about. So now we're 10-15 minutes into the lesson and we're going to actually start talking about generics. Well, it's important because you see the process. You see why we need them is because otherwise we got all these different functions here, creature, object, attackable. What if we want to just cast a Firebolt at anything, right? All right, so let's make a function to cast a Firebolt at anything. Function cast Firebolt at. All right, and then here's our basic function, right? Well, what do we want to cast it at? We want to cast it at anything. Well, the problem is that Swift is type safe, right? Swift is like really particular about stuff. So if we want to cast it at a thing, it's got to have a type. And in this case, the type we're going to call it T. Well, what the heck is T? It's the letter that they use to express generics in Swift. So unfortunately, even Swift is like, what the heck is T? So right here after the declaration of the function, or the name of the function, you're going to put these angled brackets, I think you call them, and the letter T in there. So we're going to say, hey man, there's this thing, it's called T now. And here it is. Well, that's in a nutshell it. That is a generic right there. So whoosh, boom, crackle, you hit the thing. Okay. Now let's use it down here. Can we cast Fireball at the air now? So let's see. Instead of the other functions, we're going to use this one, and we're going to cast it at the air. Let's go ahead and print it out. Cool. Whoosh, boom, crackle, you hit the gas named air. So the problem here is like, well, I want this to look exactly the same. I want the same effect to happen, right? This one says you hit the door. This one it says you hit the gas named air. It's like printing out the whole object here. So I suppose you could do different things to handle that. But let's say that you want to actually access the name up here. So you want this to say thing.name. Well, right now you can't because it's like T doesn't have a name. T is its own weird thing, and there's no like member named name in the thing called T. Well, if the thing called T was of type nameable, and that's the protocol we defined up here, then technically speaking, now we can access the name. Okay, so we just said T conforms to the protocol nameable, and there you go. Now thing.name works. What that does mean, though, is that you can't just pass anything into cast Firebolt at now. So let's say we want to cast Firebolt at the thing, and the thing is 23, right? The number 23, right? You can't do that here because it conforms to nameable. Now let's see what happens. I'm just curious if we take nameable out and we just print the thing here. Let's see if the 23 would work. I'm just curious. And yeah, look at that. Cast Firebolt at 23. You hit the 23. Okay. So pretty cool stuff. Let me undo that because I kind of like this with the nameable thing. And so this isn't really going to work right now. So I'm going to comment that out for now. 23 doesn't adopt nameable. So the other thing you can do with these generics is instead of adopting protocols here, you can adopt classes. Now you can't, unfortunately, adopt structures. So you can't say cast Firebolt at T and T is going to be a type object, maybe. It'll yell at you. It'll be like, dude, type T is a non-protocol, non-class type object. But if you have like an object class, so like you have like a class up here, and let's say class object class, then this is legit. Then anything that's in object class, you can pass into this Firebolt function here. Now it doesn't have the name thing because the object class is not currently nameable. But you get the idea. Okay, I do like having the cast the Firebolt at something nameable, so I'm going to put it back to the nameable thing, thing.name. So far, that's my favorite one. And that way we can cast the Firebolt at the air again. Doesn't do much, but it says you hit the air, which, you know, technically speaking, you're probably not. I think the best solution here is to have the Firebolt, cast the Firebolt at something that is actually attackable, which means that this one here, cast the Firebolt at the air, is you can't actually cast the Firebolt at the air. So it kind of protects you against doing stuff like that. Okay, so what did we learn? We learned about generics here, that they use the letter T, and you have to use this weird syntax here when you're declaring them inside of functions where you use this the angled braces and say T is there, and now you refer to things as T inside of there, inside of the function. We learned that you can type alias a bunch of protocols together. And we learned that Swift is very particular about being type safe, and that using generics is actually a type safe way to pass multiple objects inside of a function. We learned that generics can use protocols or classes, but not structures. So hopefully this was helpful for you in understanding a little bit more about generics. There's all kinds of excellent use cases out there, but I wanted to kind of keep it simple for this particular lesson. If you enjoyed this video, be sure to hit the thumbs up and subscribe to my YouTube channel, Cracking Code with Dave, for more videos on Swift and Swift programming.